Okay, good morning, everyone. Okay, questions about your assignment? Okay, nice music. We have to let it go. Okay, any questions? All right, so first I would like to make a comment about the quiz. Your quiz was graded and you guys should have the solution, but I will just address the question that gave you some difficulties and they were easier than some of you made them to be. So the one that gave you difficulties was number 3, which was, so it was the idea I gave you the following expression. Minus 3 tangent t. And the question was express everything in terms of sine and cosine. So I want you to kind of manipulate it to express in terms of sine and cosine. All right, so first you have a secant. And the idea is we have first, since it's terms of sine and cosine, what's secant? Secant is 1 over cosine. Minus 3, the tangent. The tangent is the sine over the cosine. And then it was the idea of basically simplifying this expression, all right? And this is where some difficulties occur. So how do we multiply? So it means that we have to take 4 cosine multiplied by that, and we have to distribute. So what do we get when we distribute? So I will have 4 cosine t times 2 over the cosine of t. So I am distributing minus 4 cosine of t times 3 sine t over cosine t. And now what does this give me? Okay, so you can think of this as a fraction, if you want, multiplied by another one. So how do we do that? We multiply across. 4 times 2, that's going to give me the 8. And the cosine is a common factor here and here. So this will give me an 8. Done. Minus. What about this piece? We multiply across 4 times 3 times the sine divided by the cosine. Now the cosine, because it's a common factor, could go, and I will be left with 4 times 3, it's a 12, times the sine of t and of the problem. Okay, so it was not, a very hard one. Now the last one you had is the second page as well. So I will go over it quickly and then I will move on to circles and ellipses. All right. So let's see what this was about. So I gave you a triangle and I did not give you, I gave you this is x and this is the 3. And then I told you that use the triangle to express everything in terms of x. Okay. And now it's the idea. So what's the cosine? So the cosine is nothing more than the adjacent, because that's a triangle, so I'm working with a triangle, over the hypotenuse. And I want everything in terms of x. So the adjacent, I know it. The adjacent is x. Now the hypotenuse. Can I express the hypotenuse in terms of x? Is it easy or hard? But we know Pythagorean. So c squared, a 3 squared, which is 9, plus x squared, means the hypotenuse is the square root of 9 plus x squared. So this is the square root of 9 plus x squared. With this in mind, the problem really falls apart. So this is going to be that cosine. For the sine.
Excuse me, I apologize.
Question?
Yeah, you're.
Yes, please.
I'm not trying to say anything, but you said cosine is adjacent over hypotenuse, which is cosine's opposite over hypotenuse. You're given x over.
What?
Am I wrong?
Adjacent. What's the adjacent to theta?
Adjacent is x, but that's sine. Sine is adjacent over hypotenuse.
No. No,
Oh,
no, no,
I
no,
am
no,
wrong.
no,
That's
no,
okay.
no, no.
That's I
No.
was wrong. Yep.
No, no, that's okay. That's okay.
Thank you. I appreciate it.
No problem. That's the opposite, sorry, over hypotenuse. Okay, which is x, which is 3 over that. Okay. The cosine 2 theta, I gave you which formula to use because I want you to be aware of them totally. And then we just multiply 2 times. The sine is the opposite over that times the cosine, which is the x over 9 plus x squared. And now how do we simplify? Now how do we multiply fraction? 2, you can think of it as 2 over 1. So the way you multiply, it means you multiply all the numerators together. 2 times 3 times x, which is going to give you 6x, divided by. Now, the square root of 9 plus x squared multiplied by the square root. So usually if you have the square root of any number, you multiply it by the square root of the same number. This is basically give you the number back. So the square root of 9 plus x squared times this will simply give you 9 plus x squared. That's the simplification. Okay, please ask question as I move on. Now, cosine 2 theta. I'm sorry. Again, I gave you the formula. It's the cosine square of theta minus the sine square of theta. Okay? And remember that the cosine square is the cosine theta squared minus that. Okay, now we already found the cosine of theta. Cosine of theta is x over the square root of 9 plus x squared minus. The sine is 3 over, so this whole thing squared minus that. Okay, and now the rest is actually, again, the rest is algebra. So let's do the algebra here. X over that, it's, so whenever you have something like a over b and you square it, it's a over b times a over b. So again, the usual. It's a times a over b times b, which is b squared. So it's going to give me x squared over the denominator square minus 3 squared, which is 9, over the denominator square, which is the square root of 9 plus x squared, the square root of 9 plus x squared. Finally, I will get x squared over. If you take the square root and square it, it will give me the number back. Minus 9 over, square it, 9 plus x squared. So finally, the same denominator, I can combine the numerator, and I will have x squared minus 9. Okay, so please go over this question. It's not very hard, it's just you guys got messed up with it. Any questions about this before I proceed further? So let's take care of the quiz. Now we're gonna back to circles. We're gonna finalize circle and we're gonna start ellipses today. So the circles, what we know so far, we should know a lot. The circles is, that means if you have a circle and you center at the origin and the radius is r, then the equation of a circle, it means the relationship between any point, so centered at the origin, radius r, and that's the equation. Okay. Now, what happens if we take the center at HK? How the equation change? The radius is r, and this is my circle. Okay, what's the equation now? Okay, Who can write the equation or tell me the equation immediately? How will it change when I change the centers? It means what's going to be the relationship between any point on the graph? Anybody likes to talk? It's fairly similar. Instead of x, I have x minus h. Instead of y, I have y minus k. And that's really the equation of a circle. Now, based on this, we are going to review a few problems, and then I'm going to move on. Okay, so I did put the homework on the bright space. I will do some of them. I will not do all of them. And all right, number 4. Find the equation of the circle with center minus 2, 1, 2, and radius 5. Okay, what's the equation? Okay, let me start picking student because I don't want to keep doing by myself. Okay, let me pick somebody. Anthony, are you with me? Anthony Vasquez, are you with us? Okay, I usually move. Aaron, can you give me the equation?
Yeah, give me 1 second.
Yeah, we have to hurry up because we have a lot to talk about. That's the center and that's the radius. Go ahead, Aaron. Okay, I'll get back to you.
So would it be x minus -1 squared plus y minus 2 squared would equal 5 squared?
Exactly. Now, is the point 2, 4 on the circle? Justify. How do you do that? Aaron? Circle. The center is -1 and 2. That's the center. And the radius is 5. So this is going to be a circle like that. Okay, that's the center.
So then no.
Is it on the circle? How can I check immediately?
I'm not sure.
Okay, the check is you plug in 2 for x and 4 for y. If the equation is satisfied, it means your point is on the circle. If it's not satisfied, the point is not. Are you with me? Okay, it means
yes.
We set x equal to 2 in the equation and y equal to 4. If it's on the circle, it means this has to be satisfied. It means this equality has to be satisfied. So I actually don't know. I'm going to plug those numbers. So I'm plugging 2 for x and 4 for y. And ask myself, question mark, is it 25? If it is, the point will be right here on the circle. If it's not, the point is not, okay? So let's see, this is gonna give me 2 plus 1, that's gonna give me a 9. And that's going to be 4 minus 2, that's going to be 4. The question, is it equal to 25? And definitely no. So the point is not on the circle. So the point is somewhere here, it's a 2 and a 4. So whatever it is, the point is right here. It's not on the circle. It's either here or here. I actually don't know, but I know that it's not on the circle. It's not here. It is either here or here. Actually, it's going to be inside if we draw a good graph. But the idea, it will not be on the circle. It means it won't be on the circumference. Okay? All right. Then number 5. Question is, give the equation of the circle whose center is 5 minus 3 and go through the point 2, 5. So here I gave you the center. I did not give you the radius, but I told you 2, 5 is on the circle. So how can we do that? Anthony, would you like to talk this time? Okay. Anybody would like to tell me? Okay. Yeah, please, Aaron. Make sure you do. Okay, who would like to check with me number 5? Who has any idea? How can I do that? So I know the center, but I don't know the radius. So how can I find the radius? But I know a point.
You would use the equation for the circle. So that would be x squared plus y squared equals r squared.
Be careful. What's the center? Be careful.
But since we don't, well, since we don't have the radius, you would use 5 squared plus -3 squared, and that would give us the radius. And then you square it.
Wait, you lost me. You lost me, honestly. What do you want me to start with? And I will go through it. What do you want me to start with?
So you would take the center point that we are given,
So what
and
do
you
want
would
me
do
to-
5 squared. And then plus y
Yeah.
squared. Yeah.
Not y squared, y plus 3
Or-
squared.
Yes.
Why?
Sorry.
That's where the confusion was. Because the center is 5 and -3. So h is 5 and k is -3. Okay, so you cannot start with x squared plus y squared. You have to start with that. Are you with me? I mean, all of you. Okay, this is equal r squared. Okay, how do you want me to find the r? Keep going. So the center is at 5 -3. It means the equation has to have this form because this is h is 5 and k is -3. Now the question is I need to find r. How can I find r using the information I have? Back to you guys. How can I use the information that the point 25 is on the circle? So I know the center. It's 5 -3. The center is here. I don't know the radius, but I know that the point 25, so this is a 2 and 5, this point is on the circle. I mean, somehow the circle has to be something like that. It has to go through this point. How can I use this information to find the r? So that's the center. Down here, that's the point. I can use this information to find the radius. Anybody? Plug in 2 and 5. Where shall I plug in 2 and 5, Kishan? So Kishan is suggesting if the point 25 is on the circle, it means you have plugged in 2 for x and 5 for y, I should get r squared, that's what we're going to do. We're going to plug in 2 for 5, and I'm going to plug in 5 for x. Basically, I'm computing the distance between those two. I'm saying this is r squared. And that's going to give me, that's a square, and that's a square. That's going to give me 9 plus, and 5 plus 3, okay, that's going to give me 8 squared plus 64 is equal to r squared. It means r squared is equal to 73. It means r is the square root of 73. And that's really the radius. So now I have the center, and I have this point on the circle. It means that this equation has to be satisfied, which is basically the distance from here to here squared. That's the r squared, and then I solve for r. Okay, we're going to do 2 more problems on the circle, and then we proceed to the ellipse. All right. Now the question is, as I said last time, equation of a circle given in this guise. So you guys should be able to do all of it. I will pick some of them. So we're going to do B. So we're going to find the equation of the circle. And I will pick one of C, D, or A, unless you have a specific question. So the question is, this is look like a circle, but it's not quite. The question is, find the standard form of each of the circle, then state the center and the radius. The standard form is this one. All right, question number 1. How can I get the standard form, please, very quickly? So what can I do from this equation to get to the standard form? Okay, Matthew. I don't know if I picked the same student. Matthew, do you have it? You are pitching. Okay, Lucas. What do you think?
I'm not sure, to be honest.
Yeah, okay, so how do you think I'm gonna, so you have 4x squared, 4y. How do you think I'm gonna go from here to here?
Wouldn't you distribute first?
No, if I distribute, there is no way I will get to that. It will be a nightmare. We can do better than this. What do you think we can do?
Maybe take out the square or try getting the square by like expanding it, like taking away from b the square. Fine.
I want to get here in the quickest possible way. I want to get to a form like that.
Then I'm not too sure, to be honest.
Anybody else can help. Because once you see it, you guys can understand. Anybody can help. We're going to divide by 4 across. Why dividing by 4 will be very helpful in this problem. I divide by 4. I will have 4x squared over 4 plus 4 equal 6 over 4. Why will this let me get close to this format? 4x squared over 4 will give me x squared. This will give me y minus 1 squared. And this last one will give me 6 over 4 is 3/2. Is this look like this format? This stage, this would look like the exact format. So this is going to be a circle where the center is. What's playing the role of h here? It's a 0. What's playing the role of k is 1. And the radius. Remember, this is the radius square. So the radius is going to be the square root of 3/2. Okay, so distributing, it will be not a good idea because I want to get to this format. So we divide by 4, so we have exactly that form. Okay. Now number C. So the idea here is I need to find the standard form of the circle. It's the same type of question. And this is, look, anything but a circle. So how did we do this problem last time? Any ideas? We did something. What did we call it? We took this expression and we did what we called complete the square. And the goal from completing the square is to get to this form. So the idea is I want to do this form. All right, so let's complete the square and I will remind you the algorithm here. So what was the algorithm? So I put the x's together and the y together. Okay, to complete the square, what shall I add to this term? What shall I add to complete the square? Nine, because what's x multiplied by, which is 18, I have to divide it by 2, which is 9. And then what should I add? Not 9. What do you think I should add? I should add 9 squared, not a 9. Be very careful. You add the 9 squared, not the 9. And then, so here, I'm going to add 9 squared. Okay, so if you have x squared plus bx, to complete the square, you add what x is multiplied by, half of b squared. That's what you add. And this would give you, this will become x plus b squared. Now y squared is complete, so I do not touch the y squared. Now finally, the goal of completing the square, which is a trick you guys need a lot. It's not like something I'm talking about here. Completing the square will allow me to take this expression and writing it something square. What square? This would become x. What should go here is whatever x multiplied by, which is the 18 over 2. Because I have a minus, it's going to be minus 9. Plus y squared equal to. Now this is minus 65 plus 81. This is, we're going to get it out of a calculator. Minus 65 plus 81. I should do that mentally, but I don't feel like it. So it's going to give me a 60. Okay. Now, once I write it in the standard form, and I can actually recognize a circle in it. So we write in the standard form to recognize a circle. Now, this expression, let me make a comment. X minus 9 squared is exactly, so you to check that you're doing the work correctly, x minus 9 squared should give you exactly x squared minus 18x plus 9 squared. It means those two are exactly the same. I am not really changing the expression. It means if you take this and you square it, you get, if you square this, you're gonna get x squared minus 9x minus 9x minus 18x minus minus plus 9 squared. You're not changing the expression, you're rewriting it as a complete square. Now, once I do that, now this is a circle. The center is, that's the h. There's y squared, it means that's a 0. And the radius is equal to 4. Okay, I let you do D by yourself for next time. I will look at E and then I will proceed. Please do those homework. That's the only way you're gonna learn, all right? So help me with E. So the idea is that first we collect the x's together. We collect the y's together. And this way we're gonna complete the square of all those. The constant term, I move it to the other side. So this is gonna give me, because those don't look like circles, have nothing to do with the original format. Minus 63. Now I take each two, and then I start completing the squares. All right, x squared plus 4x. What shall I add, all of you? What shall I add to complete the square? Whatever I do here, I do here. I add 2 squared. Now we're fine. Coefficient of x is 4, divided by 2 is a 2. We add this term square. Plus. Now, y squared, so sorry, if I should add both sides, or I will not be keeping the equality. So I add this here, I add it here. Minus 16y, now again, coefficient of y is 2. What shall I add quickly? I want quick answers. All of you should be able to tell me the quick answers. Okay. 8 squared is Matthew right? I don't know. I think 16 divided by 2 is 8 squared. I'm going to add here 8 squared. Okay. Now my completing. This expression becomes what? And this expression becomes what? There is a plus in between, and this is a bunch of stuff. When I added the 2 squared, this becomes what? Rebecca, are you with us? Rebecca. Okay. Yes, so can you tell me what is this? This is something squared. What should go here? So this is what squared? X squared plus 4x plus 2. This is x plus 2 squared. Okay, so it means if you take x plus 2, you square it, and then you distribute, you get exactly that. This is exactly x squared plus 2 squared. What about this term? This is what? Anybody else would like to answer? Okay. What term squared this will be? Why? Is it plus 8? Alex, is it plus 8? What do you think? Look at the expression. What do we have in here? Right, right. This is a minus. It's going to be 1 minus 8. Okay, so if you have a plus here, it's going to give you a plus. If you have a minus, it's going to give you 1 minus 8. And then we're done, basically. Equal. Minus 63 plus 64, that's going to give you a 1. 1 plus 4, this is equal to 5. And now I have the standard form of the circle. That's what we call the standard form of a circle. And here, the center is h here is a minus 2. The k is 8. And my radius is the square root of 5. So it's a fairly complicated form. And now I can sketch all the points that satisfy this equation by sketching the circle. Right? Please go over number D by yourself because you have to know how to handle those problems. Right. Okay, today along the same line, but we're going to talk about ellipse. All right, so at the beginning, we talk a little bit what an ellipse is and then what's the equation. So ellipse. And I'm doing this section differently than the book. If I do it like the book, you will be, I mean, you'll be totally confused. So, which is, I think it's 14.3 in the book, but I will give you the homework. So you will do the homework that I'm assigning. So the ellipse basically is the shape of an ellipse. I mean, all of you probably know the shape of an ellipse is like that. It's like an oval shape. That's an ellipse, or that's an ellipse. So you can think of it as a circle, but it's smashed. You take a circle and you smash it horizontally, or you smash it vertically, and you get what we call the ellipse. So this is the ellipse shape. It's an oval shape. That's the ellipse shape. Okay. Now, geometrically, what is an ellipse? And it's going to be geometrically, the ellipse is the following. You take 2 points. Okay. You fix 2 points. Okay, so we're going to fix 2 points. So geometrically, what's an ellipse? To have an idea what it is. So geometrically. Okay, you fix 2 points. Okay, and sometimes we call them F1 and F2. Okay, so we're going to fix those 2 points, F1 and F2. Okay, fix them just on the x-axis, then we're going to fix them on the y-axis. And we fix a number A. A number A, we fix a number A. In a circle, remember a little bit a circle. The circle is defined like this. You fix 1 point, we call it the center, and we fix a number r, we call it the radius, and the circle are all the points which are at a distance r from the center. That was the radius. The ellipse are going to do something a little bit different. We're going to fix 2 points and a number A, and I'm going to take, we're going to take all the points such that, all the points such that the distance, and this is the little bit the hard part, the distance from the point P to F1. So I'm going to fix those two and take all the points at the distance from P to F1 plus the distance from P to F2. I'm taking all the points such that the sum between from here to here plus the sum from here to here is fixed, is a constant, doesn't change. And usually it's a 2a, but don't worry about it, just worry that it's a constant number. So geometrically, before we say what the equation is, what's the ellipse? I fix 2 points, F1, F2, usually, and then I take all the points such that the sum of the distance means from here to here, the sum is fixed. So the sum is, let us say, a certain number, we call it 2a. So if this is a point on the ellipse, this point also will be on it. If this is by symmetry, from here to here, the sum is 2a. All right. Before I go any further, so the top point is the point P, right? And from here to here is a fixed number. This point is also on the ellipse, the one totally symmetric to it, because by symmetry, the sum is the same as the sum above. Now, before we go any further, let me actually show you how we can construct an ellipse. I mean, how can we really by hand create it? I'm going to show you on a small video. We fix 2 point F1 and we take a string. So we put nails here. And then I'll show you on the video how it's done. And we take a string, and such that the length of the string is a number 2a. So it's a constant string. And then I'm going to do the following. I take the string and I push it here. Take the string and stretch it. So this is loose. Take it and stretch it. And then I'm going to pick a pencil and move around with the string. As I move around with the string, we're going to describe an honest to goodness ellipse. So let me a little bit share with you how you can construct the spring, and then we talk about the equation of it. So I'll try to share that the best I can. Okay. So I hope I have the video out. Yeah. So I want to watch. This is F1 and this is F2. The nail are those points that we're going to fix. And okay, I will stop. The string, the yellow string, not all of it, the yellow string between the nails, this one and that one, this is fixed. And what he's doing is actually moving around. We're gonna get an honest to goodness ellipse. That's really how we get an ellipse. Those 2 points are fixed. This is the string I'm talking about, this one and that one. So now, as he moves around, the length is always the same. But as he moves around, he's gonna get an honest to goodness ellipse. So that's really how we construct an ellipse. So he's doing it again and again and again. That's ellipse. So geometrically, that's what it is. All right. So now we come back. So when we take this, we're gonna get this shape. Now, if I put the point I fix, if I put them here and here, I will get exactly the same thing, but my ellipse will be elongated, but it's gonna be elongated vertically instead of being elongated horizontally. So that's geometrically what an ellipse. So the question is now for us is the following. Okay, if you have an ellipse, which is this kind of picture, which is geometrically like that. The question is that if I take a point on this ellipse, and that's the hard part, what's the relationship between the x and the y? I mean, what's really going on between the x and the y? So we do a lot of algebra to be able to come up with the equation that relate x and y, but we will skip the algebra in this class, and I will give you the equation the way it is. So equation of an ellipse. Equation of an ellipse. So geometrically, it's very interesting, and actually it has a very nice property that at the end of the hour, I tell you what's nice about those points, F1 and F2. But now, equation of an ellipse. It means if I take all those points such that the sum of the distance to those is fixed, what's the relationship between the x and y? All right, so I'll write it down and then I will work it out. The equation looks like that. I know it's going to look bizarre. X squared over, it's not like a circle, over a certain number squared, plus y squared over a certain number squared equal to 1. It means this shape, this elliptical shape, have that for equation. Now, before we start studying it, let me analyze that equation a little bit with you. So I'm going to draw it here, draw the ellipse by analyzing it. Okay. First, I want to see what is the x-intercept. What do I mean by x-intercept? It means if you have this equation, that with x and y, finding the x-intercept, it means when does the graph hit the x-axis. To find where the graph hits the x-axis, usually we ask ourselves, when is y equal to 0? So here we're going to have the shape will be some kind of an ellipse. And the question is, when does it hit the x-axis? So I ask myself, what happens if y is 0? If y is 0, we have x squared over a squared equal to 1. It means my x squared, if I multiply by a squared, both equal a squared, it means my x is plus or minus the a. So this equation will have that as a shape. This point here will be the a, that's the x-intercept. And this point here will be the minus a. Okay, we're trying to, so from here to here, in this equation, this is a. Now, the y-intercept, it means this is the ellipse. When does it intercept the y-axis? To find the y-intercept, we're going to put x equal to 0. If x is 0, I will have y squared over b squared equal to 1. Y squared equal to b squared. It means the y is plus or minus the b. And on the graph, it means that this is the b and this is minus b. So on this graph, it means from here to here, this is b. Okay, so that's the equation. It means whenever you see an equation like this, very specific, x, and we're going to work with it, x squared over a squared plus y squared over b squared, and you graph this, you get an ellipse. And what characterizes the ellipse? The a in this here is from here to here, that's the x-intercept, and the b is from here to here. Now, sometimes, not a lot of times, the ellipse will be elongated because of the definition. It's going to be elongated like that. Okay, so instead of being elongated horizontally, it's going to be elongated vertically. And the same idea will go. This is from here to here, it's in A, and from here to here, it's a B. Now, usually, when is it elongated horizontally? When it's elongated vertically, it depends on A. So if A bigger than B, it means it's going to be elongated horizontally. If A less than B, it will be vertically. And this is once you have the formula, we'll do it. Now, a lot of words, vocab, and then we proceed with the example. So anytime you see this equation, you have to start, you graph all the points that satisfy this equation, we're going to get this shape, this oval shape. What are the A and the B? This is the A, and this is the B in the equation. Now, some words. The longest axis, this axis, the longest axis is called the major axis. So I draw it on the picture. So the longest axis is called the major axis. Okay, it means this axis here is called the major. In this problem, when it's elongated vertically, this is called the major axis of the ellipse. Okay. And then there is something we call the minor axis, the smallest, the shortest axis in the ellipse is called the minor axis. Okay. And ellipse has a total symmetry. It means this piece here and this piece here are mirror image of each other. This piece here and this piece here are also mirror image of each other. So there is a total symmetry in the graph. So the shortest axis is called the minor axis. So in this problem, I will do it like that. This is the minor axis. And here, this will become the minor axis. Okay. So that's the equation. This equation brings this type of picture. If A bigger than B, we have elongated horizontally. If A less than B, we have an elongated vertically. And now let us interact a little bit with this equation so it becomes a second nature to us, the same way the circle should be. All right, so let me take examples. All right. And the question is, for each of the given ellipse, it means I'm going to give you an equation that represents an ellipse. The question is, find what's the A, finds the B, so we can recognize the formula, and length of major axis and minor axis, and sketch. Okay. So we're going to take a bunch of equations and we're going to do them. So the first equation is, so that's how the ellipse looks like. That's the equation of it. X squared over 36 plus y squared over 9 equal to 1. It means if I sketch all the points that satisfy this equation, I'm going to get an oval shape. And let us analyze the oval shape. What's playing the role of A here? And what's playing the role of B? Usually that's the equation we have to keep in mind. Okay. So what's playing the role of A? Usually what comes under x squared, this is the A squared, and this is my B squared. Okay, so my A is going to be the 6, and my B is going to be equal to 3. Okay, now the sets find A and B. The length of major axis, minor axis, and sketch. All right, so what's going to be the major axis and the minor axis in this case? Right. So when I sketch here, the shape here is going to be an ellipse, but let us sketch it carefully. What is the A in the picture? And what is the B in the picture? The A is when y equal to 0, is the x-intercept. So this is from here, that's the 6, and that's the -6. The B is, this is the B. That's the B. So my ellipse will go like that. That's really the ellipse. Now, what's the length of the major axis? The major axis is the longest axis. This is the major axis. So the length here of major is equal to 12. I have 6 from here and 6 from here, and the length of the minor that's the 3, and that's the 3 is equal to 6. And this is elongated horizontally whenever A is bigger than B. So here A is bigger than B, it means it's elongated horizontally. I'm going to give you another one, but please, this time you tell me what's the A, what's the B, and you tell me whether it's going to be elongated horizontally or vertically. So example number 2. X squared over 9 plus y squared over 36 equal to 1. What's your A? What's your B? Okay, please get going. Put your answer on chat, and if you don't, I will pick on one of you. A is 3, Rebecca. A is 3. B is 6. All right, question number 2. Do you think this is going to be elongated horizontally or vertically? It's going to be elongated horizontally or vertically. Is it going to be like this or like that? Are you going to smash a circle like this? This is going to be elongated vertically. Okay, now we're going to graph, and you're going to tell me so how this is going to be. Graphing it is simple. This is the A plus 3 minus 3, and this is the B. And it's going to look like that. Okay, from here to here, that's the B, because that's what happened when X is 0. Y is going to be plus or minus, so that's the 6 from here to here. And this is going to be my 3. So length of the major is 12. And the length of the minor axis is going to be a 6. All right. Example number 3, and now I want you to be careful with this example. I'm going to give you an equation that's not quite an ellipse. It's going to look like it. And we're going to rewrite it so it's an honest to goodness ellipse. Equal 36. Okay. Now, the equation of an ellipse that we know now is the following. It has the form x squared over a squared plus y squared over b squared equal to 1. That's the equation we know. Any other equations that doesn't look like it, we have to like it to, we want to make it look like that. So how shall we do so I can rewrite that so it would look something like that? What can I do, you think? So we're going to rewrite so that I make this divide by 4. Okay, it will solve half of the problem because I can divide by 4 here. I divide by 4 here. I divide by 4 here. And it's going to give me x squared plus 9 over 4y squared equal to 9. I want a 1 in here. What do you, so it's not really, not done yet. It's, okay, it's not gonna, it's like, not like a circle. It's not because it's not a circle. Who have any idea? What can I rewrite? How can I play with it so it's gonna look exactly like that? Divide by 36, because I want a 1 in here. So I say, okay, to get a 1, I need to divide by 36. So we're gonna do exactly what your classmates suggested. Divide by 36 across. Okay, we're gonna let it look like that. So let's see, what do I mean by that? So I'm gonna take 4x squared across. Everything has to be multiplied. So it's like playing games to be able to get to this. Over 36, okay? Now, this will become my 1. Very good. But now I have 4x squared over 36. I want it to look like that. So this will give me what? 4 over 36. Now 36 is 4 times 9. This is 4 times 9. So I can simplify by that, and this would leave me with x squared over 9. Because now I have 4 is a common factor. Okay, this one, 36, again, it's 4 times 9. All right, I will get y squared over 4. Now I have exactly, okay. All right, so now I have exactly the standard form. Once I have it in the standard form, I can actually understand my ellipse. Once I told you that this equation represents an ellipse, so this is something that I'm giving you, and now we're going to use what I'm telling you to be able to apply that. So here my a is going to be the 3, because this is a squared, my b is 2. Means the a is larger than the b, so we're going to move it. It's going to be elongated horizontally, and now I sketch it because to give meaning to that. So a, it means this is 3, and this is -3, and this is my 2. That's the b, and that's the a. So this would represent this ellipse, absolutely this one. So now the length, so this is stretched or elongated horizontally. And what else? Major axis is the longest one. So the length of the major axis, this is the length from here to here. It's going to be 6. And the minor axis, so these are names that we know. The minor axis is from here to here, that's which is equal to 4. Right, I'll give you one more problem along those lines, and then we move on with shifted ellipse. So suppose I give you the following: x squared plus, let us say, I'm trying to give you nice numbers. Equals 64. And the question is exactly the same ideas. It's the same thing. It's the same ideas. And I want you to rewrite it in the standard format: x squared over a squared plus y squared over b squared equal to 1. And then we're going to identify the a and the b. So I give you 1 minute to rewrite it in the standard format. Get going. Okay, who's ready to tell me what to do and to give me the a and the b?
You start by dividing by 64.
Okay, so I divide across. We have to be very sure we divide across. I'll follow everything you tell me, okay?
Okay.
All right, we divide across because you want this to be 1, and we start to have to memorize the pattern. I mean, we're gonna memorize totally a circle, totally an ellipse, and finally next time we'll start the hyperbola. But we have to recognize how they look like. Keep going.
And from there, you keep x squared over 64.
Yes. I keep it. Yes.
And then 8y squared turns into y squared over 8.
Yeah, is she right? Definitely so, because 64 is 8 times 8. Okay, so 8 is a common factor. I'm going to simplify by it, and then this is 1. Absolutely. Okay, now what's the a and what's the b? Keep going.
The a would be 8 because you take the square root of 64.
Right, so a squared is the 64, a equal to 8. Keep going.
And b would be the square root of 8, which would turn into 2 square roots of 2.
Keep it square root of 8. That's
Oh,
not-
okay.
Yeah, I mean, It's a little bit 2 point something, right?
Yeah.
So b squared is the 8. 8 is the b squared. It means b is the square root of 8. Now, when we draw it, okay, so this is represent an ellipse, and that's, I know that I did not derive it for you because the derivation is hard and you will lose me immediately, but we have to accept it, that in equations that looks like this, the graph will be an ellipse, and that's why I'm asking you to accept that. Is it going to be elongated vertically or horizontally?
Horizontally.
Horizontally because?
The A is larger than the B.
Right. Okay. So now if we graph it, we're going to have that. A is 8. So that's 8 minus 8. And the B is the square root of 8. Now, square root of 8 is square root of 9 is 3. So square root of 8 is a little bit less than 3, like 2 point something. So that's the square root of 8. And that's the minus. So this is the square root of 8. And this is the 8. So it's going to be definitely moving like that. Okay, that's going to be my ellipse. So now the major axis, length of major axis.
The length of the major axis would be 16.
Right, and the minor?
It would be.
Don't be afraid. Don't be afraid.
I just know it'd be 8 squared plus 8 squared naturally.
No,
Would
no,
be
no, no. Don't be afraid.
Eight.
This
Would
will
it
be
be
square root
square
of 8.
Plus the square root of 8. Would it be like the square root of 16?
No, it's two
Oh.
of them.
Oh, sorry.
It's two of them. Don't be afraid. Don't be afraid. Just two of them. Okay? It's not 16. It's just two of them. Whatever the square root of 8 is, it's like if you have an apple plus an apple, it's 2 apples. That's really what it is. So it's this one plus this one is 2 of them, period. Now, if you want the actual value, you plug in square root of 8 into your calculator. All right? Okay. Now, so this is this equation. So whenever you see, that's really what I want. Whenever you see an equation like this, whenever you see something like that, you should say, okay, this represents an ellipse. And whenever you see something like this gives you a circle. Something like that will give you an ellipse. Now the question is, when for the circle, we actually said, all right, if this is centered at the origin, then we said, okay, if I make the circle centered at a different point, the equation changed. And we have x minus h squared plus 1y minus equal to r squared. Now we can do the same for the ellipse. And we call those shifted ellipse. It means suppose I take the ellipse, but I don't make the center at the origin, I shift it. So the center at a different point. The equation is going to be changed by almost the same way this one changed. So what do I mean by that? I mean the following. So I'm going to call that shifted ellipse. It means you have an ellipse and you move it. So shifted ellipse. Shifted ellipse. All right. So the idea is we have an ellipse in the same picture. But instead of having the ellipse like this, where you can think of it as the center at the origin, now we're going to shift it. So the center is the same thing, but I'm going to make the center to be at HK. Okay, so if this is A, I'm not going to touch A. So this is my A here. And I'm going to take the same thing. So I'm going to end up with an ellipse like that. This is my A. And this is my B. So basically, I take a standard ellipse and I shift it. Now, the equation will change in the following format. The equation will become x minus h squared. So whenever I have x squared, I put x divided by a squared plus y minus k squared divided by b squared equal to 1. So it's changed by the same way. The a and b are basically have the same meaning. So now it's When I shift it, this is my new ellipse, if you want. The A is always from the center till the vertex, this vertex, the horizontal vertex, and the B is always from the center to, if you want to call those vertex, to the vertical vertex. So this is the A and this is the B. Right? So with this in mind, let us practice again this kind of equation. So this is my question to you. Find center, find the center, the value of A and B, and sketch. Okay. So the goal now is like we did last time, but we're just moving the center. That's really what, so we're kind of shifting this ellipse a little bit. So the first one is very standard. So suppose I give you x minus 2 squared over 9 plus y minus 3 squared. Now, when I don't divide by anything, it means I'm dividing by 1, basically, equal to 1. Okay. So the first example is a typical standard form. Something squared over 9 plus y minus 3 equal to 1. So by analogy, let us figure out the center here. So the center would be, what's playing the role of h? Is it 2? Y minus k, my k is a 3. So that's the center of my ellipse. Now, 2. I want the A and the B. So what's my A and what's my B? Okay, now back to you. Nothing changed. What's under the x is the A squared. At this stage, nothing really changed from before. And here, I don't have anything. It means I have a 1 in here. And so this is going to be my B squared. So A is going to be a 3 because A squared is 9 and A usually we take the positive 1 and B squared is 1. So my B is equal to 1. So this is again is going to be an ellipse which is stretched horizontally, and now I'm going to graph it. Okay, we're going to graph it. So how are we going to graph? The center is at 2, 3. 2, 1, 2, 3. That's the center of my ellipse. Okay. The A is 3. It means I have to go 3 units from this and 3 units here. So these, if you want, what we call them a lot of time, the vertices of the ellipse. The B is 1. It means from the center, I'm going to go 1 unit and down 1 unit. And now I just connect. This equation will represent this ellipse. So on my picture, this is my A. That's my A, which is the 3. This is my center, which is 2, 3. And from here to here, this is the B. So it's basically you take x squared over a squared plus y squared equal 1, and you shift it so that the new center is 2 and 3. That's really the new center of your ellipse. Right. I'll give you 2 more examples along those lines. And next time we will be ready for completing the square with an ellipse. So example number 2. Again, I'm going to give it to you in a standard format, but I'm expecting answers this time. X plus 2 squared over 16 plus y squared over 9 equal to 1. And now my question is, I want you to find the center. I want A, I want B, and then we're going to sketch it. All right, what is the center in this case? Please, I want answers because I would like to do one more example with you before we let go. What's the center? What's playing the role of H and what's playing the role of K in this problem? A is 4, all right? A is 4. And what's B, Kishan, quickly? The B is 3, very good. Now we're struggling with the center. What's the center? Rebecca is telling me 2 and 0. It's half correct. Or I would say 3/4 correct. You're missing one thing. The x plus 2, this should be x minus h squared. All right, that's how you're gonna do the similarity. If this is x minus h squared, x plus 2, it's x minus 2 squared. It means my h, the h here is the minus 2. And that will give me the first coordinate. The second is absolutely correct, it is 0. Okay, so you messed up on the center. The center is minus 2 and the other one is 0. Now we are ready to basically have a very nice ellipse. So now we're ready to graph this. The center is minus 2. It's right here. That's my center. Now my A is 4. So it means I need to go 4 units from this side and 4 units from this side. And my B is 3. It means I go 3 up and 3 down. And then I connect the rest. And this is my circle. So this is the B, which is a 3. And this is my A. And this is to be 4. So you had difficulties with the center. To find the center, you said that this should represent x minus h squared. So let me figure out what's playing the role of h. What's playing the role of h is minus 2 in this scenario. Right? Okay, the last problem, and before I forget, you have a quiz next Wednesday. So please, I'll put it on bright space. Please review everything we're doing. Okay. All right. My last question is this. I want the center and everything. Now remember, this is not in standard format. So you have to start putting it in standard format first, and then we go back and identify everything. So how can I put it in standard format? Quickly. Right. Remember the standard format. Let me make sure you understand what I mean by standard format. That's what I mean by standard format. X minus h squared over a squared plus y minus k squared over b squared equal to 1. Okay, that's what we mean by the standard form. Okay. So if I want to put this in standard form, I have to divide by 16 across, like I did before. Divide by 16. And this would give me 4 times x plus 2 squared over 16 plus. So I'm always dividing by the term to the right to make this term to be 1. That's really what the technique the games we are playing. Equal 16 over 16. All right, now this will give you a 1. This will give us the y squared over 16. And this would give me x plus 2 squared. And now 4 and 16, we know it's 4 by 4. So we simplify by that, which would give me a 4. Now I have a standard format. Now I identify everything. My center now is, because I have x plus 2 squared, I'm identifying it with x minus h squared. So the h is a minus 2. and 0. The same like before. The a here, this is the a square equal to 4. So my a is 2. And my b is 4. So this make it that's going to be elongated by vertically. And now my graph is the following. Okay. My center, -2, 0. That's the center. My b, my a is 2. So this is the a from here to here. And this is the a. So I have 2 from here to here. That's the 2 in the picture. My b is 4. I'm going to go up 4, go down 4. This is the b. And finally, that's my ellipse. So that's really the graph. So this should touch here. So it's going to go like that. Right? And now in this case, the major axis has length 8. It's 4 plus 4. And the minor is 2 plus 2, which is equal to 4. And that's really my ellipse. Okay. Next time, we're going to complete the square and we're going to give an ellipse in a weird format. And we're going to manipulate it so it will have the standard form. So make sure you reviewed completing the square very well for your quiz next time, because you will have that. And it's going to be useful for us in the next lecture. Okay. So as I said, you have a quiz on Wednesday. And all the info will be on Brightspace. It will cover all about circles, everything, and circles, distance between 2 points, review the formula, and what I did about ellipse, what I did today about ellipse. Okay, so please do your homework. Okay, class is dismissed. If anybody has questions, please, you can remain.